Hello everyone, my name is Eric Masowski, and in this tutorial we're going to be taking a look at photometric lights. Now photometric lights are basically just physically accurate lights that use physical properties that we find in the real world to determine the strength, the intensity, the fall off, and so on. And so we can use photometric lights wherever we're doing lighting instead of the standard lights that come with Macs. And there's a couple features of photometric lights that really make this appealing, even if we're just doing simple direct illumination and not necessarily fancy global illumination. So let's get started. What we have here to begin with is just a very simple 15 by 15 foot cube. Now, since photometric lights use actual physical properties and physical numbers, it's very important that the scene is at the correct scale. So make sure that you're using real-world units and that everything is a logical size. Now, once we have our cube, we're just going to apply a normal modifier to turn it inside out. And there we go, just a very simple test scene that we're going to use to see what kind of effects can be achieved with photometric lights. Now, in the past, if we go over to Create, Lights, in Standard, these are our default lights that we have to work with. So we have our target spot, which really shouldn't come as a surprise to anyone at this point. And so when we render this out, you can kind of see the pattern, very, very simple patterns that it defines on the floor and so forth. So just a very uniform shape down there at the bottom. And as we know from a previous tutorial, we can adjust the fuzziness of the edge here, how much it attenuates, and its fall off. But again, those are usually very straightforward effects, usually linear or exponential fall offs. Now if we click on the drop down list and go to photometric, we have another set of lights here. We have target point, target linear, and target area. Now target point is like an omni light that can have focus. And so that's what we're going to use at first, just to demonstrate some of the basic properties. Target linear is, think of like a tube light. Target area, think of like, say, a computer screen illuminating the entire room. So let's go to target point, and we're going to click and drag from the corner down to the center of the room. And we're just going to move it roughly to the corner. Give it a little bit of space so it doesn't clip the edge of the room. Okay, and then let's do a quick rendering. Now you'll see that how the light is actually behaving. It's behaving mostly like an omni light at this point. So let's first just take a look at some of the properties that we can set. So if we go over to our modify panel with the point light selected, or with the target point selected, and take a look at some of these options. At the very top, it's almost identical to what we have with our standard lights. We have on, whether it's targeted or not, and the type that it is. We can activate or deactivate shadows, as well as exclude various objects from our shadows. Now the place where this really changes is underneath the intensity, color, and distribution area. Now with our standard lights, we basically just have a color picker and kind of like a multiplier value that specifies how strong the light is. Now here we have a lot more options. We have a distribution model. We can do isotropic, spotlight, or web. I'm just going to leave isotropic for now. Underneath color, we can specify, is this a fluorescent light? Or is the light made out of mercury? Or is it metal halide? And so we can go through and choose various types of, or various colors or tones to give our light through this drop-down list. And you'll notice that this little color box changes based on what value. Because every light, depending on what is used to generate the light, will cast its own internal color. Now there's also the Kelvin here, and we can use this to specify an explicit Kelvin value. Now, Kelvin is basically just a temperature. And if we take a look at this right here, you can see that sunlight is basically at 11,000 kelvins, or Ks. A strobe light is at 6,000, standard daylight is at 5, flash bulb 4, flood lamp, so on, and then candlelight down at 1900. Now in our case, what we're going to do is we're just going to use kind of like a high pressure sodium. We can also choose a filter color. Now the color right up here for kelvins is kind of like the temperature of the light. Okay, so the color and the temperature that the light itself gives off. Now the filter color here can be thought of as if you were putting like a colored gel or a colored transparency in front of the light. So if you want to tweak it and make it say blue for a night scene or so forth, this is where you do it. Now further on, underneath intensity, we have three different models here. We have lumens, or LM, candelas, and lux. Now if we take a look at the side again here, we can see that lumens measures the overall light output and power of the light, with 100 watts equaling 1700 lumens. And so we're pretty familiar with what a 100-watt light bulb uses, so that's why this comparison was made. Candelas measures the maximum intensity of the light, usually along the direction or the focus of the light. And then lux measures the luminance caused by the light shining on a surface at a certain distance and facing in the direction of the source. Okay, so depending on what you feel comfortable with would depend on what you use. So right now we're just going to leave it at candelas as a default. And then we also have another option here. If, say, for example, you find out that your light just isn't emitting enough energy or enough intensity, we can turn on the multiplier and then just tweak this value to completely oversaturate or just strengthen the light. When we render it out, you can see that we now get kind of like the nice colored glow to it. Now one of the really strong powers of this type of light, of a photometric light, really relies on the distribution. I mean, it's really nice that we can actually specify the majority of the light's properties using real-world settings, but one of the strongest things about these lights is the web distribution capability here. So if we change our distribution to web, and we go down to web parameters, and what this does is this allows us to specify what's called an IES file. Now these files are basically specifications or standards that light manufacturers create. And what it does is it specifies the lighting or the intensity of the light across the entire surface of the light. And it specifies also kind of like a web distribution, or kind of like how the light comes out of the light source. If you have light like a little desk lamp or a fancier light close to your computer, and you look at how it actually casts light and the patterns that it casts coming out of the lamp, you'll see that it's rarely a nice uniform circle like we were seeing before with our standard spotlight. So, okay, we're going to click on where it says Web File None, and there are several that are provided with 3D Studio Max. But if you also check on the forums, you'll see that I've included a very large collection of IES files as well. So what we'll end up doing here is we'll just end up choosing a wall wash 75 watt. Now you'll notice that it actually changed the pattern or the shape of our light source here. So now if we render it, we'll actually have to bring bring the light a little bit closer to the wall. You can see that it's a slightly different pattern than what we were having before. Now let's go to another one. Okay, so here I'm just going to choose one from the collection I provided. And you'll notice that this one has an even different shape. You can see how it kind of branches out in a very unique pattern. And when we render this, look at what it creates. It creates this nice streaking effect. And so we can increase the intensity of this light to exaggerate the effect. And it even creates very unique patterns down here on the ground as well. And so this all comes for free by using the web distribution and photometric lights. See, I'm not even doing any fancy global illumination or anything like that. But by using photometric lights, we can get these very unique and wonderful patterns just by using web and a special IES file. Now, as mentioned on the forums, I provided basically a collection of IES files. Now, the IES files themselves are not very visually descriptive, meaning that when you look at the file itself, it's very hard to tell what kind of shape or what kind of pattern it's going to end up creating on your walls. So if you're just picking the IES file for visual purposes, like you're not trying to mimic a real world light that is present in your scene, I have provided JPEG images along with the IES files. So you can see that we just chose the 51003.ies. If you open up the JPEG file, you can see kind of like the distribution that you'll get. And so I provided JPEGs for all the different IES files so that you can cycle through and hopefully choose one that matches the type of effect that you want to create. Okay, so that will basically do it for the photometric lights. Now, in the next tutorial, we're going to actually take this a little bit further and take a look at global illumination. So how these physical properties, like lumens, candelas, and luxes, how they actually transfer into lighting a room or lighting a scene. Okay, so if you have any questions, feel free to email me or post on the forums. Thanks.